Good morning, everybody. Welcome back to Microeconomic Theory II. Today, we will review the questions about the game theory. We have learned about game theory with 5 videos from the beginning to the sequential game. So, I have questions to ask, and it might be similar to the midterm examination. So, let's look at the question. Number 1. What is the difference between decision under uncertainty and game theory? You see that the decision under uncertainty is just one person make the decision under the probability of the environment, good environment or bad environment, or good luck or bad luck. However, game theory is different because game theory is about more than one player. It means that at least we must have 2 players, and the results of one player depends on the action of another player. Therefore, the difference between decision under uncertainty and game theory is at first, number of players, second, the result. The number of players of game theory must be more than 1, and the results depend on another side's action. Question number 2. What is dominant strategy? Dominant strategy is the strategy that a player always chooses, no matter what another side chooses the strategy. Whatever strategies that another side plays, this player will choose this strategy forever because it dominates other choices. It dominates other strategies. So it is the best to react. Therefore, that is the dominant strategy. Question number 3. What is Nash equilibrium? Nash equilibrium is the matching between 2 reaction functions. So, if one reaction function does match with another reaction function, that point is Nash equilibrium. But if one reaction function does not match with another reaction function, then there is no Nash equilibrium. So the Nash equilibrium is the matching between reaction functions of players. Question number 4. What is the importance of Nash equilibrium? Nash equilibrium is the result of game theory. It is the solution of the game. It means that the game will end up at that point. If we have just one Nash equilibrium, then that is the solution of the game. However, what if we have many Nash equilibriums? Then we have to solve the game by the focal point theorem or the focal point equilibrium. And in another case, if we don't have Nash equilibrium, we have to use mixed strategy, and we apply the probabilities to settle the solution of the game. Question number 5. What is mixed strategy? Mixed strategy is an event that has many Nash equilibrium or no Nash equilibrium at all. In this case, we cannot find the solution of the game directly from the Nash equilibrium. We have to use the focal point equilibrium as suggested by Thomas Schelling to define the probability of each player and find an equilibrium that is the tendency of those players that will be interacted. The most possible point that both players will find the solution. That is the focal point equilibrium. And with using the probability, when we have no Nash equilibrium at all, we can find a point that both players will settle and it will be the solution of the game. So, mixed strategy is when we cannot solve the game by just only one Nash equilibrium. And we use probability to find the answers of the game. Question number 6. If both players have dominant strategy, therefore, how many Nash equilibrium there are in the game? The answer is there will be just only one Nash equilibrium in the game when both players have dominant strategy, because one player always chooses one strategy and another player always chooses another strategy. Then that strategy of player A and that strategy of player B cross just at one point, and that point is the Nash equilibrium. Question number 7. What is Pareto optimality? Pareto optimality is the best choice that yields the highest social welfare or social benefits. It is the win-win solution. Technically, it is defined as a point where one player's benefit cannot be higher than that unless making another player's benefit smaller or lower. It is the point where we cannot find the better result. So it means that it is the highest point, the highest welfare of the society. Question number 8. Prisoner's dilemma. What is the prisoner's dilemma? Prisoner's dilemma presents a problem where we have a Pareto optimality, but we cannot achieve it. We achieve just only an equilibrium that is below the Pareto optimality or worse than Pareto optimality. Because we cannot communicate to each other. Without the communication, we can achieve the higher equilibrium, the higher benefits, the solutions with the higher benefits or the Pareto optimality. Therefore, the way out of prisoner's dilemma is the communication, and the communication brings about the cooperative game. Question number 9. What is the difference between competitive game and cooperative game? Competitive game is a game where both players try to do just to maximize their own benefit without thinking of another side. However, cooperative game both players trying to maximize the social benefits, which is the summation of both players' benefits. One player may drop his or her benefit, but when the social benefits or the summation of both players' benefit is larger, then if they're trying to achieve that by communication, by cooperation, then it is the cooperative game. Question number 10. Is free trade a cooperative game? Yes, of course. When you are doing free trade, you trade with other countries. You use the comparative advantage, the concept of Ricardo, and you will gain from trade. Both countries gain from trade and gain higher benefits, and the summation of benefits of all the players or all the countries will be much more than just keep one country consume just solely the products produced by that country. So open up the trade and joining the free trade, then it is better, and we can achieve Pareto optimality by free trade. Question number 11. What is the difference between simultaneous game and sequential game? Simultaneous game is when all players move at the same time. But sequential game is a game when one player moves first and the second player moves later. So it's about timing of the move. Of course, in sequential game, one player who moves first should have the advantage because he or she can set the objective of the game and he can set the strategy and force another player to move accordingly. However, it is not like that. If the second player do something that can harm or can hurt the first player, for example, imitate the product. In the imitation game, if the first player innovates the product and the second player always imitates the product, then the first player pays more for the research and development investment and cannot gain as much as he or she expects. The second mover or the imitator will gain more because he or she spends less and gain more because of the popularity of the product in the market. So the spending of marketing cost is less but gain higher profit. That is the second mover's advantage. Therefore, it is not always that the first movers would have the advantage over the second mover. There may be some cases that the second mover will have the advantage over the first mover. In our classes, I have two challenges for you. First, what is the probability that the game will not have the solution? A game catch me if you can. If you try to use 50 and 50, probability of the police to go to the town 50% and the probability of the police to go to the forest 50%, and also you use the probability for the thief to go to town and go to the forest 50% as well, then you cannot find a solution. That is one example of the probability that yields no solution for the game. And the second challenge, the tree of sequential game of the second mover's advantage. The hint for this second challenge is that if you look at the payoff of the first mover's advantage, you see that the payoffs of the first movers always be positive, and let the payoffs of the second movers negative, always like this. Therefore, if you change a little bit in this second mover's advantage and you switch the position of positive and negative payoffs, for example, you let the first movers have always the negative payoffs and the second movers always the positive payoff, that is one choice. And another choice, if you let them have both positive payoffs, but one smaller for the first mover and another larger for the second movers, that's okay, that's fine. However, how you draw the choice? It is the first mover have two choices: develop this product or develop that product, product A or product B. And after that, another player decides to imitate product A or not imitate product A. And for product B, the second movers can choose to imitate product B or not imitate product B. You can do this tree for the sequential game of the imitation game. And you will see that the second mover will always be advantage over the first mover. I hope you enjoyed the class and ready for the midterm examination. And good luck for everybody for the midterm examination. If you have questions, you can ask me by email or line. So everything here in the review questions will be very similar to the midterm examination. See you in next class. Have a nice day. Goodbye. 再见. สวัสดีครับ